This lesson is on part D, our challenge questions. It is optional, but always have a go. And those of you in the advanced group, make sure you go through these questions and correct them as well. Now, with the first one, so it's already got writing on it, but I've circled the subtraction sign and a negative sign because we say two negatives makes a positive. Those brackets don't have to be there. It's just saying it's a negative half that we're subtracting. So I'm going to rewrite it as and what I'll also do to save some space, whenever we have mixed numbers, so mixed fractions, I can turn that into an improper fraction. So I'll do that as well. So 2 times 3, so we'll go times and plus. So 2 times 3 is 6, and 6 plus 1 is 7. And it's a negative still, so I've got now 7 over 2. We keep the same denominator, plus 1/2. So that's what I'm left with just by doing those two things. Now, when it comes to adding, in this case, we're adding these fractions, we already have the same denominator because we know when adding fractions, we must have the same denominator. But it's really important with working with negatives, we write this step. Write them on one fraction line. So they both have a common denominator of 2. And that negative, it's sitting in the middle, but we can put it on top. So now it becomes a negative 7 plus 1. So I can see that a lot more clearly. And we also know there's invisible brackets on there, so we have to go negative 7 plus 1 first. I'll just continue it here. Negative 7 plus 1 leaves me with negative 6, so equals, so over, same denominator. Now, I can see there's one negative, so what I'm saying now is negative 6 divided by 2. That might work, but I know if I've got one negative and there's division or a fraction, the answer will be negative. And 6 divided by 2 is 3. So my final answer was negative 3. With B, check your operations first. I've got multiplication and division. That is not subtraction. That is saying a negative quarter. Okay, so my operations are multiplication and division. In that case, I can look at the whole thing and determine if it's going to be a negative or a positive. Because there's one negative, the whole thing will be negative because there's an odd amount. And if I did it the long way, I've got a positive times a positive, which is positive, and a positive divided by a negative will be a negative, okay? So that's the way I would do it. And the next thing is multiplication and division are equal operations. So we work from left to right. That will work as well. And if I just focus on my multiplication here, I can see I've got 150 on top and on the bottom, so that cancels to 1. And I've also got 6 and a 12. So divide by 6 is 1. 12 divided by 6 is 2. So I'm now left with 1/2 times 1 over 1, which will just leave me with 1/2. Okay? And then divided by, I've still got that quarter. It's not a negative anymore because I've taken care of my negative. Because I know the final answer will be a negative. Just don't forget to write it with each step. Now at this point, I've got division left. And I know I have to flip the second fraction. So I'll be left with 1/2 times 4 over 1. And I'll just continue it here. And now I can see, yep, the whole thing is negative. And I'll be left, I can simplify before I multiply. That becomes a 1, that becomes a 2, because divide them both by 2. And I'm left with 1 times 2 is 2 over 1, because 1 times 1 is 1. And of course, we write our final answer as negative 2. Never leave a 1 on the bottom. It should always be invisible. And it should have been a negative. Now with the number 2, evaluate the following. Now I've got a power 2 out there, but that negative is just sitting on its own. There's no brackets. So when we have no brackets, this means there's just one negative sitting there, and that 2 is being squared. So it's like I have a little bubble there. Only that 2 is being squared. I don't have brackets. If I had this minus in the brackets and then the squared outside the brackets, we can see the negative is being included, okay? So it's saying 2 negatives makes a positive, but we don't have that. So we've got 1 negative, 2 squared is just 4. So the answer would be negative 4. And the calculator will also verify that for you. Now with B, I've got a square root and a decimal. Now we've learned how to multiply decimals. And the trick is to, whether we're multiplying decimals or trying to work out a missing number or numbers, ignore the decimal. So if I didn't have a decimal, I would have the square root of 144. Now, we know what the square root is telling us. There's an invisible power 2 there, and it's saying a number times itself, so the same number to give you what's inside. In this case, I've got 144. Now, I know my 12 timetables. I'm going to have 12 times 12. So if I had the square root of 144, the answer would be 12. Now, the difference is this has 1.44. So the 12s have to have, I've got 2 decimal places here. So I have to have 2 decimal places in this calculation here. And the way to do it, and remember, these 2 numbers have to be exactly the same. Well, to have 2 decimal places in total, I'll put a decimal place in that one. So that's got 1 decimal place and the same one in this one. So in total, I've got 2 decimal places. So that means 1.2 times 1.2 would be 1.44. Okay, so I bring it back 2 times. So the answer for this one would be 1.2. Alrighty, with C. Now C, we've got a negative power. And we have learned a couple of ways on how to do this. The first time we ever saw negative powers, we had to set up a table. So this might be the easiest way at this stage. And then if I put, just say 3 to the power of negative 2 here, 3 to the power of negative 1, 3 to the power of 0, 3 to the power of 1. I might just do one more. 3 squared. I can use patterns to work out, in this case, negative powers. So if I have no idea how to work this out, well, if I've got a pattern up here, so all the bases are 3, and it goes down in a pattern 2, 1, 0, -1, -2, -3. I'll start off with the ones I know. 3 squared I know is 9. 3 to the power of 1 is just 3. 3 to the power of 0 I know is 1. And I also learned that by using patterns. So I'll start drawing up the pattern. Now, to get from 9 to 3, I have to divide by 3. To get from 3 to 1, I have to divide by 3. So the pattern is to divide by 3. So even if I had more numbers here, the whole pattern would be dividing by 3. Now, if I have to fill in this one, well, what's 1 divided by 3? Remember, if I've got 1 divided by 3, and avoid writing decimals, we can just keep it in fraction form. We'll just have 1 over 3. That's still saying 1 divided by 3. So I now have 1/3. And then if I keep dividing by 3, what's a third divided by 3? A third divided by 3, and remember we have to turn division to times, and I flip it. I now have a third times 1 over 3. So I've got 1 times 1 is 1, 3 times 3 is 9. So now I've got 1/9, and there's my answer. So 3 to the power of a negative 2 will just equal 1/9. And if you have a look, if I continued, 1/9 divided by 3 is actually 1 over 27. And if I continued one more here, 3 cubed is 27. That's why it's good to keep it in fraction form. There's actually the same pattern. So when I look at the numbers here, 3, 9, 27, I see that pattern in my denominators, 3, 9, 27, and it will keep going. So when you have a negative power and you're not sure what to do, set up a table and work out the pattern. Or the trick is, if you just go 3 squared, which is 9, put the 9 on the bottom. So we have 1 over 9. That's the other trick that we can do. All right, with D, I've got the square root of 16 over, and then the 16 over 100. Now we learned that maths rule or law. If we've got a big square root, I can write, there's a fraction in there, I can write the square roots individually. So it's actually saying square root of 16 over the square root of 100. If I do them individually, square root of 16 is 4, because 4 times 4 is 16. Square root of 100 is 10. So I've got 4/10. Remember, we must always simplify our fractions in maths. So 4 divided by 2 is 2. 10 divided by 2 is 5. So I end up with 2/5. Now this one down here, I think it was missing from your exam. It didn't print. So you can just copy this down and have a go first. But here I've got multiplication. So I'm going to simplify anything from top and bottom first. And I can see straight away square root of 8 is the same as the square root of 8. Same number, so that's cancelled. Also, outside the square root, there's a 5 here. And outside this square root, there's a 5 there. Because they're both outside, I can also cancel them. So they're gone. And now I'm left with, I'll just rewrite it. I've got 1 times the square root of 100 over 16 times, square root of 16 times 1, which is going to be the square root of 16. And I've ended up with almost a similar thing to the previous question, but they're sort of the other way around. So I'll just rewrite, I'll just evaluate. So square root of 100 is 10 over square root of 16 is 4. Simplify my fraction. I end up with 5 over 2. And this time I've got an improper fraction. So I'll turn it into a mixed number. 2 into 5 can go 2, 4. So 2 times remainder 1 over 2. So 2.5 is my final answer. All right, with 4, it says simplify the following expressions. So I've got algebra and I'm dividing here, and then also got fractions and multiplying there. So we learned with these ones, we just have to simplify our numbers like normal. So I've got 50 and 100. I know 50 divided by 50 is 1. 100 divided by 50 is 2. So straight away, get my fraction line ready. I've simplified my numbers like a normal fraction, 1/2. Now, I'll keep the 1 up there just in case there's nothing else on top. Now, with the algebra, we learned all we got to do is remove the smallest amount. I've got 2 A's on the bottom and 5 A's on top. The smallest amount is 2, so it's gone from the bottom. But 5 take away 2 from the top leaves me with A to the power of 3. And now I've got 4 B's on the bottom and 7 B's on top. So cancel my smallest amount. And 7 take away 4 is 3. So I've got B to the power of 3 on top. Let's just fix this up. Now I've got A cubed, B cubed over 2. And that would be my final answer. The 1 can become invisible, it's just sitting there. I've only got 2 on the bottom. Now over here, same process, simplify before you multiply. Anything from top and bottom, so I can go diagonally or vertically, it doesn't matter. So the first thing I see is a G over here and a G there. So 1 G on top, 1 on the bottom, they can cancel. I can't cancel that G as well. Only 1 from the bottom, 1 from the top. So just be careful. I've got 2 H's on the bottom, and then 3 take away 2 is just 1 H. There's a power 1 there if you want to write it. I've got 4 A's on top, 10 A's on the bottom. So the 4 can go from there. 10 take away 4 is just A to the power of 6. And these H's are on top, so I can't cancel. So let's rewrite what I've got. I've got G, H to the power of 5 over 1, so 1 there, times H over A to the power of 6. Sometimes it helps to rewrite it because it does get messy. Nothing else I can simplify. I'll just write it here. Now we just multiply them. So I've got G, H to the power of 5. So G, H to the power of 5 times H over, and then 1 times A to the power of 6 is just going to be A to the power of 6. Now here, be careful. Now I'm multiplying. So I've got H to the power of 5 times H. I add their powers. 5 plus 1 is 6. So I'm now left with G, H to the power of 6 over A to the power of 6. Okay, and there's my answer for that one.